Video, we will derive the equation for voltage gain for the inverting operational amplifier and the voltage follower circuit. We know in a closed loop configuration of op-amp, a part of the output is fed back. You see here V0 is the output that is fed back to the input. By doing this, we are able to operate the op-amp in this linear region so that we will have a control over the output. For op-amp with negative feedback, there are two golden rules which you should remember to analyze any circuit. The first thing is that the current drawn by the op-amp is zero. That is, the op-amp does not essentially draw any current. You can see here, this is the current and you have a voltage source here. So the current is entering the node N, but the same current is leaving the node. It means that no current is entering the op-amp. Similarly, here in this terminal also no current will enter. So this is the golden rule which you should remember. Next one, the differential voltage, that is the difference between the two input voltage will be always zero. So if this is connected to ground, this will also be connected to ground. If this has some potential, for example 10 volt, this end will also have 10 volt. For an op-amp with negative feedback, there are two applications. One is the inverting amplifier and the other one is the non-inverting amplifier. So in inverting amplifier, the output, op-amp output is fed back to the negative pin, that is the inverting pin, and the input is given to the inverting pin, same pin. In non-inverting amplifier, the op-amp output is fed back to the negative pin only, but here the input for the op-amp is fed to the positive pin. So in the previous video, we have seen about the inverting amplifier and its derivation, voltage gain derivation, where we will get the voltage gain as minus Rf by R1, where Rf is the feedback resistor and R1 is the input resistor. So you will get the output voltage will be always out of phase with the input. So this in case of inverting amplifier. You want to know about the derivation, you can refer to the previous video. In this video, we will see about the non-inverting amplifier. So if you see the non-inverting amplifier, the same feedback resistor is connected here and R1 is the input resistance, but this R1 is connected to ground. The input voltage is applied to the non-inverting input. So V1 is the input voltage which is applied to the non-inverting input of this op-amp. Now let us write the nodal equation. So we have this node N. Let us write the nodal equation. Vn minus 0. I am taking at this node. So Vn minus 0 divided by R1 plus Vn minus V0 divided by feedback resistor Rf is equal to 0. Now what is this Vn? You have to remember the golden rule. The difference between these two voltages will be always 0. So if this pin plus pin is connected to V1, this potential will also be equal to V1. So we can write Vn is equal to V1. So in this equation, let us replace Vn by V1. So you will get V1 by R1 plus V1 minus V0 by Rf equal to 0. You can simplify this one. If you simplify, you will get this relation V0 by V1 equal to 1 plus Rf by R1. So you can see here, this gain is positive and it is 1 plus some value is there, Rf by R1 is there. So by changing these two resistor values, you can change the gain of this op-amp. Another thing, instead of a constant DC voltage, if I give a sinusoidal voltage, what will be the output of a non-inverting amplifier. So this red color one will give you the output of the non-inverting amplifier. Just it gets amplified. The output will be in phase with the input. Now we will see a special case of non-inverting amplifier. That is a voltage, that is called a voltage follower. So suppose, let us take, you have two resistors here, feedback resistor RF. I am making this resistor as 0. 0 means I have to short it. So let me short it like this. Then R1 I am making it infinity. So infinity means it's open. The circuit is open. Now let us draw it again. So this will be like this. So here input is there. The output resistor is 0. RF is 0. So I have shorted it. And this input resistance I have made it open. So I didn't draw anything here. So this circuit has high input impedance and low output impedance. Now let us derive the voltage equation. What will be the voltage here? This voltage is V1. So this point is also V1. But this V1 and V0 are connected. So V0 by V1 I can write it as 1. So, or V0 is equal to V1. Output and input are same. So I can say that in this circuit, the output follows the input. So if input changes, the output will also change. So the output follows the input. So this circuit is called a voltage follower. And we can also say the gain is unity here, 1. Gain is equal to 1. So it is also called a unity gain amplifier. Let us see the applications of voltage follower. Suppose I have a high impedance voltage source which is supplying a load. If the load has a very low impedance, according to Ohm's law, the current drawn from the source will be very high because I is equal to V by R. If R is low, I will be very high. So to avoid such instance, we can do one thing, like we can connect a voltage follower circuit in between the source and the load. You can see here, this is a voltage follower circuit where the input is connected as the source and the load is connected at the output of the op-amp. We know this is a voltage follower circuit, so V0 will be equal to V1. So whatever you give, it is going to come here. Okay. Now here the problem is that it draws more current from the source. This is a voltage follower. So voltage follower has high input impedance. So it will not draw any current from the source. So your problem is solved. Moreover, the advantage of voltage follower is that it has low output impedance. It means that you can connect the load easily. Where you can use the voltage follower circuit. Suppose you have a sensor and you want to measure a temperature or a current or a voltage. The output of the sensor will be in millivolts. So in such circuits, you cannot draw more current from the source itself because you want the output of the sensor information without any distortion and you want to process it. So the sensor signal itself is very weak. So in that case, you can connect a buffer. So here the input will be the output of the sensor. You are giving to a op-amp which is connected in open voltage follower configuration. So now this op-amp will not draw any current from the source. It will not draw any current from the source or the sensor because it has high input impedance. Similarly, it can drive the ADC easily because it has low output impedance. So let us summarize what we have seen here. We saw about the non-inverting amplifier. So the closed loop gain of the non-inverting amplifier is 1 plus RF by R1, where RF is the feedback resistor and R1 is the input resistor. A slightly modified version of the non-inverting amplifier is the voltage follower circuit, where you make the RF is equal to 0 and this R1 as an infinite value. So you will get V0 by V1 is equal to 1. So this voltage follower has many advantages. The main thing is that here the output follows the input. So if you change V1, the output will also change. So the output follows the input, and it is called a unity gain amplifier because the gain is unity. It has high input impedance and low output impedance, and it can act as a buffer. If you like the material, do subscribe to Read Electric Vehicle channel and share it with your friends. Thank you.